So we talked about object. Object is nothing but a point of intersection of incident rays. While if we talk about image, so image is defined as point of intersection of reflected rays or refracted rays. Alright. So now let's talk about real and virtual images. Real and virtual images. So if light ray after reflection or refraction actually meets at a point, then real image is formed. Okay. So let's say there is a mirror, a light ray incidents at this point, okay, and gets reflected back. There is another ray which incidents at this point and gets reflected this way, okay. So they will never meet. These two rays will never meet, right? They will meet at infinity, but not at some near about point. Yes or no? So you cannot find the image at infinity. So instead of that, what we can do? This is a principal axis, okay? So if you see closely, if you just draw a dotted line from these 2 points, they will meet at this point, right? Yes or no? Let's call this O. So this is called a virtual object. What it is called?
A virtual object.
Right? So as you can see, let me draw another figure here. So this is the situation. This light ray incidents at this point and goes in this direction. First, let's draw a principal axis, okay? From where we can define all the distances, okay? There is another ray which incidents at this point and gets reflected back this way, okay? So what happens? Now you cannot trace the object, right? Because it is at infinity. As you can see, these rays are coming from very far distance from this mirror, yes or no? So instead of that, we can do a dotted line, yes or no, in the direction of incoming ray. Are you getting my point? And we can treat this point as an object, but a virtual object, okay?
Alright.
If you see from this point, it looks like that these rays are going in this direction, yes or no? Or they are coming from this direction, yes or no?
Right.
So this point O acts as an object, okay? It's a virtual object. Are you getting my point? It's not a real object. And at this point, where the two rays meet after reflection, this point is nothing but our image, okay? Are you getting my point? Yes.
Makes sense.
No? Let's take another example, okay? What if object is nearer to the mirror? Right now we are dealing with a plane mirror, yes or no? This one's the plane mirror, right? Now let's say the object is there at this point, okay? This is our object. So you can take two rays out of it. Let's say it incidents at this point, another one at this point. So it will get reflected back, yes or no? You know the laws of reflection. So where will be its image? As you can see, these two rays will never meet, right?
Right.
So what to do? How to get an image? So you can extend this ray, yes or no? These reflected rays. And where they meet, that's the point of intersection of these two rays. And that is the exact position where we are going to get our image, okay?
Alright.
So since this image is behind the mirror, that's why it is called a virtual image. Are you getting my point?
Yeah, makes sense. And the
Good.
virtual image is not real, right?
Yeah, it's not real.
Got it.
Good. Generally what
Mm-hmm.
happens, this is our plane mirror, right? If there is an object here, let's say right now you are standing here, okay? So what you will see is that yourself at the same distance inside the mirror, yes or no?
Yes.
So right now let's say you are at 5 meter from the mirror, so you will see yourself in the mirror at 5 meter inside the mirror, right? So this is your image, but virtual image, right?
Mm-hmm.
Good.
Good.
So let's talk more about formation of images by a plane mirror, okay?
Mm-hmm.
All right. So this is a mirror, and what it does, let's say there is this person. So he can see himself, right? Inside the mirror. Yes or no? Same
Mm-hmm.
person, right? So when you look into a plane mirror, this is our plane mirror, okay? Flat plane mirror. You see an image of yourself that has three properties. First property is what? The image is upright. The image is upright, but laterally inverted. Yes or no?
Right.
Second, the image is of the same size as you are, right?
Right. And it's the same distance away from the mirror.
Very good. As you are. And third is the image is located as far behind the mirror as you are in front of it. Same distance, right? Good.
Mm-hmm.
So let's draw a figure and let's understand this thing, okay? So this is the figure. There is this plane mirror. This is our principal axis. There is this object A. Okay.
Okay.
Okay. Now if you start moving in this direction, you will reach at point B, yes or no?
Mm-hmm.
This is your image at the same point, yes or no? But inside the mirror, right?
Right.
So
Right.
your image moves in right direction or left direction? What do you think?
Right.
So it will move in right direction, right? So this is how it behaves, right?
Mm-hmm.
Let's take another case where a pawn, or you can say a king of chess.
Mm-hmm.
This is our plane mirror. This is the ground, okay? And there is this pawn, or you can say king of a chess.
Mm-hmm.
So in this figure, you can take a light ray from the top of this pawn, okay? Or you can say king. So it will get reflected in this direction, yes or no?
Yes.
But if you see from here, let's say this is your eye, okay? If you look from this point, you will realize that pawn is not here. but inside the mirror, somewhere at this point. Are you getting my point? Yes or no? If you
Yes.
extend this ray inside the mirror, so this is the top of this king, right? So the eye, it appears that the ray originates from behind the mirror, right? To the eye, it appears that the ray originates from behind the mirror, right? Somewhere back along the dashed line. So actually rays is going on in all the direction, okay? But only a small bundle of such rays is intercepted by the eye, okay? There are many, you can draw many rays, right? Out of this, I mean emerging out of this king or pawn, okay? Of chess. But only few rays can enter your eye, right? Yes or no? And to study it mathematically, to apply physics, we only take one or two rays, okay?
Right.
Now if we take two rays, what happens? This is the mirror. There is this king. This is one ray. This one's the second ray. Okay. So two rays are going inside your eye. Okay. So what you will see is that the king is at this point, right? Behind the mirror.
Right.
Alright. So this is our object. This is our virtual object. Okay.
Right.
Sorry, virtual image. So all the rays that leave a given point on the object, no matter what angle they have when they strike the mirror, appear to originate from a corresponding point on the image behind the mirror, right?
Sorry.
I said all the rays that leave a given point on the object, no matter what angle they have when they strike the mirror, appear to originate from a corresponding point on the image behind the mirror. Understood?
Right.
So this image, the image is inverted if the extended object lies perpendicular to the plane mirror. This is a very important point. The image is inverted if the extended object lies perpendicular to the plane mirror. Good? Understood?
Got it.
Good. Now let's do one question, okay? This is y-axis, this is x-axis. Here is our mirror, okay? Let's call it M. Let's call it N and M, okay? The coordinates are given, okay? The coordinates of mirror. This is 4 3 and this is 4 2. That means in x direction it is 4 meters, right? Now there is our object at this point. Let's call this object A. We need to find the region on y-axis in which reflected rays are present. Okay. So what happens? Let's take two rays. Okay. Out of this object. So one incident at point M, another one will incident at point N. Okay. And it will get reflected this way, right?
Right.
So this is N dash point and this is M dash point. Okay. So for plane mirror, distance of object from mirror is equal to distance of image from the mirror, right?
Right.
Hence the image of point A, this is our point A, in the mirror is at what point? So
Sorry.
first of all, let's form one image. Okay. So since it's a plane mirror, you can extend these lines, right?
Right.
So it will be somewhere here. Let's call this point A dash. Okay.
Right.
So what will be the coordinate of this A dash point? That is what we need to find, right? Okay, how far it is.
Oh, would it be 8 4? Would it be 8 4?
This is 4 and the coordinate of A is 2 0. Okay.
Oh, so
Yeah.
if M is 4 2 and A is 2 0, then the difference in X is 2. So our X coordinate would be 6, and
This will also be 2, right? So x coordinate is 6. Yes or no?
yes, and so the Y coordinate would be
0.
also 2. Right?
No, the
Oh,
y coordinate will be 0 because this
Right,
point is
right.
on the x axis, right?
Right. Yeah.
Yes or no?
Yes.
What about this n dash and m dash? How to find n dash and m dash?
Mm. I'm not sure.
These are actually the ray is this way, okay, straight. But unfortunately, my drawing is not that good right now, so that's why.
Oh, so it would just be.
This point is 4 2, okay. So this
So if
that means
that's-
this is 4. This is 2, sorry. This point is 4 3. That means this is 3.
Oh, so one would be 2.5 and one would be 3.5.
Here the answer is m dash will be at 0 6, or you can say at 6, and n dash would be at 9, okay.
Oh.
So it's a typical geometrical question, okay. Actually this is the thing, okay. This is a dash. Alright.
Right.
This is our mirror and this is our point A. Alright. This is n dash, m dash. So you need to find the location of m dash and n dash. That's upon you, okay.